Hello students, now in this video we will discuss about the unsaturated hydrocarbons. We know the unsaturated hydrocarbons contain the carbon-carbon double or the triple bond. Hydrocarbons which contain the carbon-carbon double bond are called as alkenes, and the hydrocarbons where we find carbon-carbon triple bond, these are alkynes. Now first let's discuss about the alkenes. Alkenes have a general formula of CN H2N, and what we find that there is a carbon-carbon double bond in alkenes. So if I take the carbon 1 here, C1H2, so which means you have a carbon 1 and the 2 hydrogen atoms there. But as we know that a carbon has a valency of 4, so if you have a molecule with C1H2 formula, here in this structure the valency of the carbon is not complete, the 2 valencies are incomplete in the carbon, so therefore the C1H2 molecule actually does not exist. It does not exist. Why? Because it is highly unstable. The valency of the carbon is not complete, so therefore the first member of the alkene family is not C1H2. Now let's take another example. Suppose we have a C2 molecule, then the hydrogen atoms will be 2 into 2, that is 4, C2H4, which means that you have a carbon atom, 2 carbon atoms, and there should be a double bond between the 2 carbon atoms. Two valencies of the carbon are now complete. Now we need to add 2 more hydrogen atoms here only, and this carbon also 2 more hydrogen atoms. So this is a C2H4 molecule which is stable. Okay, so this is the first member of the alkene family, C2H4. The next member of the alkene family will be C3H6, right? 3 into 2, 3 carbon atoms, the number of hydrogen atoms will be 3 into 2, right? So that is 6, C3H6. Okay, then the next member will be C4H8, 4 into 2, that's 8. So we have to multiply the number of carbon atoms by the 2 to get the number of hydrogen atoms, right? 4 into 2, that's 8. So C5H5 into 2 is 10, C5H10. Then C6H12, right? Now let's try to draw the structure of the C3H6 molecule. This is a 3 carbon compound, 1, 2 and 3, and since it's a member of an alkene family, there should be a double bond. So you can have a double bond. Let's say we have a double bond over here, right? Now the valency of this carbon is 2 valencies are complete, so it needs 2 more hydrogen atoms. So I'm going to add 2 hydrogen atoms over here. The central carbon here is 3 valencies are complete, so it needs only 1 hydrogen atom to complete the valency. The terminal carbon is 1 valency is complete, so it needs 3 more hydrogen atoms. So total number of hydrogen atoms you see here 1, 2, 3, 4, 5, 6. So 6, 3 carbon atoms. So this is the C3H6, right? Now let's draw the structure of the C4 member. Again, there are 4 carbon atoms, 1, 2, 3 and the 4. And since it belongs to the alkenes, I can have a double bond. You can put the double bond anywhere, right? Anywhere. Let's say we have a double bond over here, right? And now I'm going to add the hydrogen atoms to complete the valency. This terminal carbon is 2 valencies are filled, so it needs 2 more hydrogen atoms. This carbon is 3 valencies are complete, 2 from here, 1 from here, 3 complete, so it needs 1 more hydrogen atom. The central carbon here, now this one, 2 valencies are complete, it needs 2 more hydrogen atoms. This carbon, it needs 3 more hydrogen atoms, right? Now total number of hydrogen atoms 1, 2, 3, 4, 5, 6, 7 and 8, right? So you got the C4H8. Similarly, we can draw the C5H10, right? C6H12, exactly the same way. Let's draw the C6H12. 6 carbon atoms, 1, 2, 3, 4, 5 and 6. Now have one double bond. Let's say the double bond is here, and let's complete the valencies by adding the hydrogen atoms, right? Sufficient number of hydrogen atoms. The terminal carbon is 2 filled, it needs 2 more hydrogen atoms. This carbon is 3 valencies are complete, 2 from this side, 1 from here, so it needs only 1 more hydrogen atom. This central carbon needs the hydrogen atom 2, right? This one also requires 2 hydrogen atoms. This one also 2 hydrogen atoms. The terminal one here is one valence is filled, so it needs 3 more hydrogen atoms, right? 3 more hydrogen atoms. And as we learned, now let's say, suppose we have a 7 member hydrocarbon, right? 7 member alkene, C7H72 is 14, right? C8H16, C9H18, C10H20, right? Now let's, C1H2 member does not exist. The first member of the alkene family is C2H6. So for the hydrocarbon which contains 2 carbon atoms, we always use the term eth, right? For the C3 we use the prop. For C4 carbon we use the but. C5 we use the pent term. C6 we use the hex. And C7 we use the hept. C8 is oct. It refers to the number of carbon atoms, right? C9 is none. C10 is dec. Now, since this molecule belongs to the alkene family, so I am going to use the name ENE right here. So I am going to use the ENE. So it will be ethene. Complete name will be ethene, and this one will be propene, and this one will be butene. ENE represents that it belongs to the alkene family. So this is pentane, hexane. So this will be the heptane, octane, nonane, and this is decane, right? So now let's summarize the hydrocarbon alkene family here. Now this is the name and this is the general formula, right? The CnH2n, okay? C2H4, this is the first member, so name is ethene. C3 is propene. Prop represents 3 carbon atoms. ENE represents that there are double bonds, right? There's a double bond. And butene, pentene, hexene, heptene, octane, nonane and decane. And again randomly, let me draw here the structure of this pentane. How should I draw the structure? As I said, we will write down first the number of carbon atoms. How many carbon atoms are there? 5. So 1, 2, 3, 4 and 5. Since there is a double bond, so you can have a double bond over here, right? So you can put a 1 double bond there and then add the hydrogen atoms to complete the valencies. 2 hydrogen atoms on this one because 2 are filled there, and this carbon, it needs only 1 hydrogen atom because 3 valencies are filled here, 2 from here, 1 from here, and this one gets 2 hydrogen atoms, okay? This one gets 2 hydrogen atoms, and this terminal one, it gets 3 hydrogen atoms. So this is the structure of pentane. You can draw any molecule. You can draw octene also, right? So octene, there are 8 carbon atoms. So I'm going to draw 8 carbon atoms. 1, 2, 3, 4, 5, 6, 7 and 8. and let's have a one double bond anywhere, right? Let's say it's here, and I'm going to add here the hydrogen atoms, right? One here, one here, so 2 to this carbon, 1 to this one, 2 hydrogen atoms will be over here. All these carbon atoms, they will get 2 hydrogen atoms each. Okay, this one gets 2 hydrogen atoms, and this terminal one, it gets 3. So total number of hydrogen atoms: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So 16 hydrogen atoms and 8 carbon. So this is octane. This is the structure of the octane. Okay, so hope you got the concept. Thanks for watching the video. Bye for now.